Okay, this is the beginning of Unit 8. Unit 8 is dealing with confidence intervals. Confidence intervals. So what these things are is they're, in essence, approximations about what an average is. So kind of generically, what this is going to be dealing with is this. Say we don't know what mu is. I don't know what the average of some sort of information is. I don't know what mu is. Mu is more specifically the population average. All right, so think of this maybe as like being Independence High School itself. I don't know what the average height of students are. I don't know. And it would take me a long time to figure it out. And so what we can do is, instead of taking a population average, what we can do is we can take an X bar, which is a sample average. All right, we can take a sample of that population. Now, it's not going to be as accurate as the population average because that is the most accurate. So think of this as being like our statistics class. All right, so it will give you an idea of what the average is, but it won't get you the actual average. All right, so in essence, what a confidence interval is going to be is this. We're guessing at what the average is. I don't know. But to be on the safe side, what we do is we create this this plus or minus this error factor that in essence we can have. So we gather up some information, and so what we say is, okay, these averages should be the same. However, just to be on the safe side, we're going to add what we'll call a margin of error. And so we'll say, just making up numbers, that if the average height of our classroom was 5'6", we can come up with this margin of error various different ways. And we can say, okay, the average is actually between 5'8", and then we can take off this margin of error, and we say, oh, it's 5'4". So we're not narrowing down the average to an actual number, but rather we're kind of giving some confidence that it's somewhere in between this. And that's in general what confidence interval is. Okay, we are obtaining information that we don't have all of the information for, so we take our best guess and then we create this margin of error, creating a confidence interval. So the average heights of students at Independence High School is somewhere between 5'4" and 5'8". Now, is that the actual answer? I don't know, but we can say, we can give some sort of confidence, like I'm 80% sure of this or something. Okay, this is what a confidence interval is. All right, a few formulas and things like that you'll need to get the ball rolling for today. Okay. The first and foremost is what the deuce is a confidence interval. So a confidence interval is, again, a guesstimation of this average. And so what you're going to do is you're going to take a sample minus E and a sample plus E. And again, E is that margin of error. So again, what this is we're taking a guess at what the average is, and then we're adding E and subtracting E from our guess, from our sample. Okay, another thing to get this ball rolling is, what the heck is our margin of error? What is our E in this situation? And so we will get various equations for this, but today this is going to be ZC sigma divided by the root of n. Okay. So right now, this is the formula that we're going to use. Okay, so there's a couple different variables in here that we'll be getting. Okay, n is the sample size. So again, if we're taking a sample, we're getting an x bar, which is an average of a sample. Okay, if we're taking an average of a sample, that sample has to have a sample size. Okay, so of our classroom that has 30 students, the sample size would be 30. And then there is this ZC, which is a Z-score. And so obviously where you're going to be looking for that is on the Z table. Okay, we're going to be looking on the Z table. Now you'll notice on one of the sides, there's the Z table, and then there's this little box that has these different things down here. That's actually what we're going to be looking at. Okay, so yes, it's on the Z table, but it's that little box that's on the bottom of one of the pages. Okay, let's take a look at some of these problems and let's get this ball rolling. Okay, so suppose a certain breed has an average weight of 27.3 pounds. Okay, so we took a sample. Based on previous studies, we can assume that the weights of these dogs have a normal distribution with a standard deviation of 3.1 pounds. So we're given a sigma. Okay. For a small group of 23, that would be our sample size. We looked at 23 dogs to get this information. We want to find an 85% confidence. So our confidence is going to be 85%. Okay. Let's go ahead and get this thing going. So we are working towards getting a confidence. And so the first thing that we need to do is we need to figure out that margin of error, which again is ZC sigma divided by the root of n in this situation. Okay, so we have the majority of the information right now. So we know what sigma is, we know what n is. But what the heck is this ZC? That is our first question. And so again, where we get this is the Z table. So let's bring up a Z table here real quick. And I must not have gotten it on this one. So actually, give me 7 seconds. I apologize for this. I was not prepared right now. So I guess we'll just take 1 second. Okay, that's the table right down there that I need. So let me... I don't know if I can take it right in here. Oh, I can. Haha. Okay, perfect. So this is what I need from that Z table. Okay, so on with the show. Okay, so here we have levels of confidence, and we have these ZCs that come off of this. So looking back to this, we want a confidence of 85%. So what that means is we have a confidence of 85%. So the ZC of this particular problem is going to be 1.44. And again, this is found on that Z table. So this implies that our ZC is 1.44. Now we have all of the pieces necessary to make this margin of error. And so I'll physically, this is going to be 1.44 times the standard deviation of 3.1 divided by the square root of n, which is 23. So again, this is going to be 1.44 times 3.1 divided by the square root of 23, which is 0.9308. Okay, that is our margin of error. Consolidate some of this chaos here. Okay, now we're ready to construct the confidence interval itself. So the confidence interval is x bar minus e is less than mu is less than x bar plus e. So this middle piece is going to be this mu. Okay, that doesn't change. Okay, what we are now going to do is we are going to get an answer to this x bar minus e and this x bar plus e. And that will be a confidence interval. Okay, so let's take x bar, which is 27.3, minus e, which is 0.9308. That comes out with 26.3692. And then we have x bar plus e. And that is our end result right there. That is our confidence interval. So again, I don't know what the weight of this certain dog is, but I am 85% sure that it's between 26 and 28 pounds. Okay, the following data is about annual profits per employee for some representative companies in financial services. Assume that the standard deviation is 8.9. Okay, let's say that the preceding data is representative of the entire sector of quote unquote successful financial services. Okay, these are all successful companies. Finding 90% confidence interval for the annual profits per employee for all successful companies. Okay, don't round answers again. All right, so here we go. We need an x bar, which is the average of our sample. I don't see it right now, so what I can do is I can find it. I don't think it's mentioned anywhere. No, I can find it. So that's 47.6, 39.8, 59.7, 56.3, 53.6, 69, 59.5, 41.7, and 47.4. And I see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 things that I just looked at. So this came out to be 52.7333. I don't usually do it that way, but the standard deviation that they set forth is 8.9. The sample size in this case was 9 companies, and I want to have a confidence of 90%. So I go to this margin of error, which again is ZC, sigma divided by the root of n. All right, I have everything but that ZC, that's going to come from the confidence itself. So this implies that the ZC of 90% is 1.645. So in this particular problem, this is going to be 1.645 times sigma divided by the root of n. Okay, again, let me consolidate the chaos here. All right, and now let's go ahead and actually construct our confidence interval. So our confidence interval in this situation is x bar minus e is less than mu, which is less than x bar plus e. So again, this middle piece is going to remain that mu, and all I have to do is find the answers to the flanks. All right, so this is 52.7333 minus e, which is 4.8802. And then I also have to take x bar plus e. All right, so this is the confidence interval that they were asking for. So the profits per employee of a successful company is somewhere between $47,000 and $57,000. Okay, now in question B, this is a hypothetical question. This is a hypothetical question, which is saying, if I were to construct an 80% confidence interval, will this be longer or shorter? All right, and I'll walk you through this one. Okay, currently, the confidence was 90%. And so that had a ZC of 1.645. They say, what if I change this confidence to 80%? Well, that would turn a ZC 80% to 1.28. So I went from here and I went that direction. Notice what happened to that number. 1.645 turned into 1.28. Okay, AKA ZC just got smaller. ZC just got smaller. You have to show all this stuff. All right, so ZC got smaller. Okay, big whoop. What does that do? Well, the next step that we took was E is equal to ZC sigma divided by the root of n. All right? And in the previous step, we just saw that ZC just got smaller. So my question now is, how does that affect E? All right, you may recall from last chapter that we defined how different things affect things. So this is a multiplication, this is a multiplication, this is a division. Okay, so if you multiply by a big number, your answer is going to get big. If you multiply by a small, your answer is going to get small. If you divide by a big, your answer is going to get small. If you divide by a small, your answer is going to get big. All right? So multiplications are the same, divisions are opposites. So in this particular case, I am talking about a multiplication number, the ZC. So if the ZC got small, that means E also gets smaller. One more thing. So the question is ultimately asking, what is happening to the confidence interval? All right. right, so a confidence interval is in essence the average minus E and the average plus E. Okay? So in this situation, if E is small, okay, if the E is smaller, right? So think about this. If I take a number, okay, I'll call this X bar. Okay, and that's assuming that's what E is, right? And I add an E, and I subtract an E, right? Let's say E is a really, really small number, 2. Okay, that would imply that this would go from 7 to 3. Okay, a length of 4. Okay, now let's make E a really big number. E is really big. Let's say 4. Okay, so that would imply that I would add 4 and subtract 4, making a length of 8. So what this just said is the bigger E gets, the longer the interval is. The smaller E is, the smaller the interval is. So big E, big interval. Small e, small interval. Here we have an E that is getting smaller. So what does that do to the interval? It gets shorter. So these are questions that are kind of like a mathematical breakdown. You're not actually doing any math. You're just kind of stepping through the process. Okay, almost done here. Okay, part C of this same question is asking, if you are a manager of a local bank and your computation of average profits per employee was 41,000, so we have this company and our profits are 41,000, would you say that your profits were low compared to other successful banks? Use a confidence interval to compute your answer, explain your answer. Okay, don't say that it's low. I'm going to change this question. Is our average, is our computation, and I'll give you some options. Is it below average? Average? Or above average? This is our new breakdown. Don't say if it's low or not. All right. And here's what this is asking for, and this is how we answer this question, is this. If we go back to question A, what we're in essence saying is this is average. This is the new average. So average is not a specific number. It's not a singular number, but rather it's a range of numbers. That's the new average. So if our number is anywhere between 47.8 and 57.6, then we are average. We are quote unquote average because we're between those two numbers. However, if we are below the 47.8, then we are considered to be below average. Right? We're below average if we're below that 47.8. And also, if we're above that 57.6, then we're above average. Below average or above average. And if we're in between, we're average. So, in this question, question C, we as a company have profits of 41. So where in comparison to our interval, where is 41? 41 is below average. So use this confidence interval to say what you need to say. Our profits are below average. Why? because $41 is below the lowest average of 47.8531. That's why. So other ways that this answer is going to be answered. Okay, other ways that this answer, depending upon the number that they give you. Okay, you would say something like this. If they gave you the number 65, if they say 65, what would you say about 65? I would say that is above average. Why? Because 65 is above the largest, or excuse me, the highest average of 57.6135. So you would just change it where appropriate. So it would be above average because it's above the highest average of 57 blah, 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 blah. The last way that this could look is, what if they gave you the number 50, where it's in between the two numbers? And then what would you say about 50? Well, 50 would be average. Average because 50 is between the averages of 47 and 57. So in essence, you're kind of using the same sentence structure as this. It's just you're turning out different critical numbers. So it's below average, average, or above average. Why? Because blah, blah, blah is below. It's between, or it's above the lowest, or the averages themselves, or the highest average of blah, 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 blah. Okay, new question. I think this is back to the normal problems. A random sample of 422 claims had an average of 3,750 with a standard deviation of 385.56. Find a 90% confidence interval. Okay, so 90%, looking at the ZC, 90% is 1.645. So we turn that into a margin of error. Brain fart there for a second. So we take our, sorry, this should have been an X bar. I'm sorry, X bar of a sample. That's our confidence interval. So that's on average how much money is paid per claim. So let's go ahead and do the other side. It is pretty much the same thing. Okay, here we go. It says the average of a bird species is 635. Notice how that's the sample with a standard deviation of 0.48. With a small group of 14 birds, we want a confidence interval of 80%. We take a look at the ZC that is going to be created from that 80%. So 80% is 1.28. Okay, 1.28 is that ZC. Now we go ahead and construct our margin of error, which is ZC sigma divided by the root of n. And so that's going to be 1.28 with multiplied by 0.48 divided by the square root of 14. And so in this situation, 1.28 times 0.48 divided by the root of 14, we have 0.1642. Okay, that is our margin of error. So far, so good. So far, so good. And so we round this out with the confidence interval is the sample average minus E is less than the population average, which is less than the sample average plus E. So the middle will remain this is less than, mu is less than, and then I just have to find the answers to the two sides. So I take X bar minus E and then I take my sample average plus E. So this species of bird, its population average should be between 7.1 and 7.5. Okay. I am going to use my calculator in this one because I don't want to make a mistake. So 51, 43, 72, 67, 57, 43, 57, and 51. Okay, I need to get some information from this, so what I'm going to do is I'm going to calculate one var. Calculate one var. Here we go. And so what I notice in this situation, that my, again, don't round. So the average of this sample is 56.5625 with a standard deviation, and that's straight up given. Don't mess that up. 10.15. Don't take whatever's on your screen here. Take whatever the problem gives you. The sample size of this situation was 8. Okay, there's 1, 2, 3, 4, 5, 6, 7, 8 here. And we want a confidence of 90% in this situation. So that will allude to that our ZC is going to be 90% is 1.645. The ZC in this situation is 1.645. Okay, we make our margin of error. Our error is going to be ZC sigma divided by the root of n, and this is going to be 1.645 of sigma, which is 10.15, divided by the root of n, which is 8. 5. So 1.645, 10, 15, root of 8, and we get 5.90032. Okay. Putting this to use, we see that our confidence interval is going to be our average minus E to our average plus E. So the middle will remain this mu, and so I take my x bar minus E and then I take my average plus E. Okay, so that is the average of whatever. I don't even know what we're talking about. Successful companies, something like that. Successful companies again. Okay, question B is the breakdown of the mathematics. Okay, so right now we have a confidence of 90%. That was from the previous question, which had a ZC of 1.645. So now I want to make a confidence of 75%. So what I noticed about the ZC of a 75%, that it's 1.15. So ZC just got smaller. ZC literally just got smaller. Okay, so ZC got smaller. We take that to our margin of error, our error factor, or margin of error. So E is equal to ZC sigma divided by the root of n. So we just made ZC smaller. ZC happens to be a multiplication number. So because I multiply by a small number, my answer is also going to get smaller. Okay, so if my confidence interval is x bar minus E to x bar plus E, and E just got smaller, what does that do to the confidence interval if I add and subtract by a smaller number? That means if I add and subtract, this will be really short. So this just got shorter. So as a manager, blah, 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 you found that your profits were, okay, again, you're not saying if it's below or whatever, don't pay any attention to this. So define what is your average in comparison to these other things? And so I see that our average is below average. Why? Because 47,000 is below the lowest quote-unquote average of, the lowest average was 50.7218. Okay, now we're talking about plasma, stuff. And so we see that the average is 41.5. with a standard deviation of 6.70. We took a sample of 47 firefighters, and we want a confidence of 90%. Okay, so 90% is going to imply that the ZC in this situation is 1.645. So the ZC in this particular problem is 1.645. So we go to our margin of error. Again, don't round. So E is equal to ZC sigma divided by the root of N. And so this is 1.645 times 6.70 divided by the root of 47. So that's 1.6077. Take it one more time to the actual confidence interval. So the confidence interval in this situation is x bar minus E is less than the actual average, which is x bar plus E. The middle stays the same, and I find the two different answers. So I have 41.5 minus 1.6077. And then I need to take x bar plus E. There's your confidence interval.